Hello everyone. In this video we look at the drawbacks of the Lewis theory. Now both the Lewis causal approach as well as the Lewis Langmuir theory, they attempted to explain the concept of chemical bonding by the basis of octet rule. Okay, and the main success of this theory is that it was able to explain how atoms are able to form chemical bond and thereby able to achieve this octet arrangement in their valence shell. And the scope of the theory is limited to just explaining how the molecules or ions rather come into existence based upon the octet rule. But there are other things about the chemical bonding, especially the bond parameters, like the concept of bond length, bond enthalpy or bond energy, bond angles, and the associated shapes of the molecules. So a lot of things are there which were not touched upon by the Lewis theory. So in this video what we'll do is we'll look at what are the drawbacks of the Lewis theory and what has paved the way for the subsequent theories, whether it is the valence shell electron pair repulsion theory, that is the subsequent theory that has come. Then we have valence bond theory and then molecular orbital theory. Okay, so once we go through the drawbacks of the Lewis theory, right, we will be able to understand what is the need for these subsequent theories. First thing, when we look at the idea of chemical bonding as per the Lewis theory, it is basically the achievement of the octet. But if you look at some molecules, right, even though after the formation of the bond, the central atom will be having less than octet, which means, after the formation of the bonding also, if you count the total number of electrons surrounding the central atom, right, it will be still less than 8. And this particularly happens in cases where the central atom is having less than 4 valence electrons, like you talk about say BCl3. So you can see boron, after the formation of 3 bonds, it will have only 3 valence electrons, right? So it will form 3 bonds. You can see 3 shared pairs. So when you count what is the overall number of electrons of boron, right, what is it? It will be just 6 electrons after the formation of the bonding. If you look at the beryllium case, beryllium has 2 valence electrons, it can form 2 bonds. You can see it is able to form 2 bonds, whether it is BeH2 or BeCl2, whatever the molecules that beryllium forms. You can see over here there are 2 shared pairs. So if you count the total number of electrons that will come to the beryllium after the bond formation, it will be just 4. Same will be the case with lithium. Lithium has got 1 valence electron, it will form 1 bond. So the effective count of electrons is just 2. So what we see is that whether it is the lithium or beryllium or boron, which are having 1 valence electron, 2 and 3 respectively, right, they are not able to reach the octet structure even though after the formation of the bonding. And we can have other examples also, like AlCl3, BCl3, BF3, all of them, right, the central atom will not be able to achieve the octet after the formation of the bond. So you can see aluminum chloride, right, aluminum will form 3 bonds, 1 with each of the chlorine. Aluminum has got 3 valence electrons. It belongs to what? 13th group, correct? So after the formation of the bonding, right, what you will see, the effective count of electrons on aluminum is just 6 only. It is not able to reach the octet. So if the basis of the Lewis theory is that the molecules in which we are talking about the chemical bonding happening, the atoms will be able to achieve the octet structure. But what we see is that even though the BCl3 or BF3 or AlCl3 or BeCl2, all these molecules do exist, but here we see that the central atom is not able to reach the octet. So these kind of molecules, right, we will be calling them as either incomplete octet or less than octet molecules. Okay, so these molecules we'll talk about what is the chemical significance of them later, but we do have molecules where the central atom will be still having less than octet arrangement. So this is one of the drawback of the Lewis theory, because Lewis theory says what? Lewis theory, as per it, the boron, if it is engaging in the bonding, means it should be able to reach a stable arrangement of 8 electrons in the valence structure, right? but that is not happening here. So this is one of the drawbacks of the Lewis theory. And we also have examples of molecules that have total number of electrons to be odd, like we have NO, we have NO2. Okay, so NO2, these molecules, right, they are examples of what? The odd electron species. That is what we call them as. So what is it that we have about the odd electron species? So look at it. If you think about the nitrogen forming a double bond with oxygen, right? Yes, the oxygen octet requirement is completed. But what about the nitrogen? Nitrogen will not be able to reach octet. So when you have total number of electrons in that molecule to be odd, if you have a diatomic molecule, then definitely what you see is one atom will not be able to meet octet. So one atom will not meet the octet requirement. Okay, so if you think about the case of N2, right, here what is the just count the valence electrons. Okay, what is the valence electron of nitrogen? 5. Another nitrogen 5. 5 plus 5 is what? 10. So when you see nitrogen forming a triple bond with nitrogen, in this case what we see, both the nitrogens are able to achieve the octet. We have discussed about this in the Lewis diagram, Lewis dot structures. Okay, but in case of molecules like NO or NO2, we will see that the odd electron species, basically one of the atom will be left out. Okay, so if both nitrogen and oxygen are forming bonding, right, obviously nitrogen as per the Lewis theory, it should not be engaging in the bond formation if it is not reaching octet, right? So this is how the odd electron species, right, one of the atom will not be able to have the octet. So octet will not be satisfied for all the atoms. This is another drawback with the Lewis theory. Then while we talked about a less than octet structure, we also have examples of molecules where the central atom will reach what we call as expanded octet, or we can also call it as extra octet. Means what? It will go beyond 8 electrons. Once the bonding is happening, right, the total number of electrons when we count, it will be beyond 8. Okay, so this generally happens for the atoms that have along with the s and p orbitals, also d orbitals in the valence shell. Like if you look at the elements beyond third period. So what is the third period elements? Third period elements are what? The sodium, then magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Okay, so this is the third period elements and beyond, so including third period. Okay, so what about third period onwards? Remember, in the third energy level we will be having what? S subshell, p subshell as well as d subshell. So the d orbitals also can be engaged in the bonding. So the elements in and beyond the third period, this will not happen for the second period elements. Okay, they will be happening for the third period and after that. Like in the third period, what do we see? They'll have 3s and 3p as well as 3d also will be available. Okay, so that is the reason why from the third period and after, what you see is that these elements can be forming expanded octet. Okay, like if you look at pf5, look at pf5. If phosphorus, what is the total number of electrons? 5 valence electrons. It will use these 5 valence electrons to form bond, one with each of these fluorines. So if you count what is the total number of electrons on phosphorus, right, after the formation of bonding, what is it going to be? 10 it will come. See, 5 shared pairs are there, right? So it is what? 5 into 2 means it will be totally coming as what? 10. So what is this? The central atom is able to reach the total count of electrons more than octet. See, if we are proposing that the idea of chemical bonding is to reach octet, then the atom should stop once it is reaching octet, right? It should not go beyond octet. Okay, so this is the drawback that we have with the Lewis theory, because Lewis theory says that atoms are engaging in bonding to reach octet. If that is the case, phosphorus should not go beyond 8. Okay, there are examples, like even you talk about SF6. In this sulfur, what is the number of valence electrons? 6. It will engage in forming 6 bonds, one with each fluorine. So if you count what is the total number of electrons on sulfur after the bonding, right, it will be what? 6 pairs are there, 6 bonding pairs. Totally it will be 12. This is also what expanded octet. Even you can take the example of H2SO4. In H2SO4 you can see sulfur is forming a single bond with an oxygen, single bond. Here it is forming a double bond, here it is forming a double bond. You count it, what is it? This is 4 plus here another 4 shared pairs, here 2 and another 2 here. So totally what is it? This is 12. So in sulfur, in H2SO4, sulfur is able to reach what? Expanded octet. So these molecules, right, they disobey the basic idea of the Lewis theory, because Lewis theory talks about what? Reaching octet and getting stability, right? If that is the case, there should not be any molecule where the central atom is able to have more than 8 electrons after the bonding. But these molecules do exist, they are stable, and that is a drawback with the Lewis theory. And the entire Lewis theory concept is based upon what? It is based upon the octet rule. So octet rule, what is the basis for the octet rule? The chemical inertness of the noble gases, because we see that the elements with NS2, NP6, a kind of an valence shell electron structure, these are the noble gases, okay, except the helium, neon, argon, krypton, xenon and radon. Okay, so we talk about the chemical inertness of the noble gases. But some noble gases like krypton and xenon, okay, more particularly xenon, okay, they form stable compounds. In fact, xenon, right, we'll talk about it when we go to the P block in the +2. Like we'll even study the reactions, the formation, the methods of preparation of the xenon compounds. So xenon forms compounds with electronegative elements like oxygen and fluorine. Same will be the case with krypton also, okay. But xenon forms more number of compounds, more stable compounds, okay. So we can have XeF2, we can have krypton F2, we can have XeOF2, like that, okay. Xenon oxides, xenon fluorides, xenon oxofluorides, okay, all these are possible. So if we say that the other elements are trying to achieve octet because octet is the most stable arrangement, and if you see that some of the elements, the so-called octet elements itself, are engaging in bonding, means this puts a question on the very basis of the Lewis theory, because after all Lewis theory is based upon what? The stability of the 8 electron structure, right? If the elements having 8 electron structure itself are participating in the bonding, means that is a question on the very basis of the Lewis theory. And Lewis theory, right, even the Lewis dot structures, they only explain how the atoms are bonded to each other in a molecule, okay. Lewis theory does not account for the shape of the molecules. Like when we talk about say something like a BeCl2, we'll learn about them little later. So we'll see that this molecule is having what we call as a linear shape. All the 3 atoms will be along a straight line. Whereas a similar formula, H2O, here we'll have oxygen and 2 hydrogens. This will be having a bent shape or a non-linear shape. Okay, so how these shapes will come, we'll learn about it later. But why different molecules with similar formula are having different shapes? That is not being accounted for. In fact, the Lewis theory doesn't even touch upon the aspect of the shapes of molecules. And it does not even explain the relative stability of the molecules. Means what? The stability of the molecules is explained by using the concept of what we call as a bond enthalpy or bond energy. It is basically the energy required to break a bond. So this aspect also is not touched upon by the Lewis theory. So Lewis theory doesn't talk about the concept of shapes of molecules and also the stability of the bonds, which we will measure in terms of what? Bond energy or bond enthalpy. So we have a separate video on these bond parameters. There we will discuss in detail about these things. Not just that, when we look at the Lewis theory, we keep on saying that the valence shell electrons will be participating in the bonding, so that in the valence shell the element will be able to reach the octet. But when we look at some of the elements in the D block and F block, right, they would not only be able to engage the valence shell electrons, but they will also be able to engage some of the electrons in the inner shell. Like, just to give some quick understanding, right, if you look at the 3D series, 3D series means the elements scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. This is the 3D series elements. Okay, 10 elements will be there. Correct. Now the 3D series elements, right? They will have the outer part of electronic configuration as 3D 1 to 10, 4s, 1 to 2. This is the general arrangement. Okay, this is the general arrangement. So the 3D series elements, they will not only be able to engage the 4s, because 4th shell is the outermost shell for them. Okay, they will not only be able to engage the electrons of the outermost shell, but they will also be able to engage the inner d subshell electrons. So the d and f block elements, what we will see, we can study a little bit more about them. So we'll have a separate chapter itself, d and f block elements, that will come in +2. Okay, so we'll talk about how the d block elements and f block elements, they will be able to engage not only the outermost shell electrons but also the electrons of the inner shells. This is against the basic idea on which Lewis theory is proposed, because Lewis theory is proposed by considering that only the valence shell electrons will be participating in the chemical bonding. So this is another drawback with the Lewis theory. Now we look at a question. Existence of which of the molecules is not as per the Lewis theory? What are we supposed to tell? Existence of which of the molecules is not as per the Lewis theory. Now look at it. H2S, sulfur is bonded to 2 hydrogens. Okay, sulfur, what is the covalency of sulfur? Sulfur is in the oxygen group, right? Sulfur covalency is what? 2. Number of valence electrons are 6. Sulfur, the valence electrons are what? 6. So covalency will be what? 2. Okay, now sulfur is able to form one bond with one hydrogen, another bond with another hydrogen. If you look at the remaining electrons, right, sulfur will have 4 of its own electrons. We will see that the sulfur will be able to achieve the octet. Hydrogen anyway cannot achieve octet, it will only achieve duplet. So this is possible as per the Lewis theory. What about ammonia? We have discussed enough about it. Okay, so ammonia, nitrogen is forming one bond with each of these 3 hydrogens, and it will have 2 more electrons, which will be the lone pair. If you count total number of electrons of nitrogen, it will be what? 8. It is able to reach octet. Okay, in the case of H2S also, sulfur is able to reach octet. So this is also possible. What about NF3 case? Nitrogen is able to form one bond with each of these fluorines. Okay, it will have 2 of its own electrons remaining, thereby nitrogen will reach octet. Not only that, fluorine, right, each of the fluorines, after forming one bond, they also will be able to reach the octet. So fluorines also will be able to reach what? Octet. So we can see this molecule satisfies. Nitrogen is able to reach octet, and all the 3 fluorines, right, they are also able to reach the octet. Means this is also possible. Now I think, if you have analyzed 3, we got our answer. What is it? BCl3. In fact, we discussed about it, right? What is the situation with BCl3? It is, what is it? It's a less than octet molecule. What is BCl3? Less than octet molecule. Why? After forming 3 bonds, boron, right, has 3 valence electrons. It will form 3 bonds, one with each of the chlorines. By this bonding, chlorine will be able to achieve octet, because chlorine, what is the covalency of chlorine? 1. Chlorines will be able to reach octet. But what about the story of the boron? Boron, after forming the 3 bonds, it will reach only 6 electron structure. It is what? Less than octet. So the existence of the BCl3 is not satisfactory as per the Lewis theory, because Lewis theory talks about the atoms reaching octet after the formation of the bonding. Correct. So this is about the drawbacks of the Lewis theory, and to address these drawbacks and explain the chemical bonding in more comprehensive manner, further attempts have been made by scientists. One in terms of making some modifications for the basic idea of the covalent bond theory itself, and in terms of explaining the shapes of molecules, we have valence shell electron pair repulsion theory, and further we'll also talk about the valence bond theory and the molecular orbital theory. Okay, we'll see them in the next set of videos.